the distributive property. We have used the distributive property to evaluate expressions, and now we're going to use the distributive property to factor polynomials. And we'll be solving some equations in the form ax squared plus bx equals 0, but that'll be it towards the end. Our vocabulary is factoring, factoring by grouping, and the zero product property. All right, so let's get started. Distributive property. You can use, we have had these polynomials that we've distributed, right? And we distribute it this way. Now we're going to do, and we get some product out here. Like in this case, it would be 2x squared minus 6x plus 14. We're going to look at the end product now and try and figure out the reverse. We're going to be given this, and we're going to figure out what are the factors. Okay? That's called factoring a polynomial. We're going to work backwards. Let's look at this example they've given us here. We have 1.6w squared plus 6w. Well, I'm going to factor 1.6w squared, and it factors into 1.6w times w, doesn't it? And 6w factors into 6 times w. Then I look at both of these terms, and I say, what do they have in common? They both have a w, so I'm going to pull the w outside, and what do I have but 1.6w plus 6? That is known as the oops, my bad. I've never done that before in my life, have I, right, guys? Just kidding. That is known as the factored form of 1.6w squared plus 6w. So this is the factored form, okay? This right here. So factoring, here's the definition for factoring, is when a polynomial, factoring a polynomial means finding the completely factored form, You remember factoring, right? Factor 24, 2 times 12, right? 2 times 6, 2 times 3, that's 2 times 2 times 2 times 3. Okay, that's a completely factored form. We're going to do basically the same thing with these polynomials. Pretty exciting stuff. Okay, here we have 27y squared plus 18y. Ooh, I don't like this marker. We'll switch to green here. Okay, well, let me factor that. That's 27. How does 27 factor, right? 3 times 9, 3 times 3, right? So 27 is 3 times 3 times 3, and y times y. Plus, factor 18, we have 2 times 9, 3 times 3. So that's 2 times 3 times 3. So 18y would look like this, 2 times 3 times 3 times y. And then I could look at them and say, well, what do we have in common? Well, I look here, and we have 2 3's and a y, and we have 2 3's and a y here. So 3 times 3 is 9y they both have in common. We can pull that out, and what do we have left? We have a 3 and a y plus a 2 and a y. Easy enough, guys? And will you have to do this? If you do, you may go ahead and do it out on the side. If you can look at 27 and 18 and think about what is the greatest common factor of those 27 and 18 and do that in your head, then you may do that, and you may pull 9y straight out of there, okay? All right, let's look on and try something else here. Maybe you're going to do guided practice. No, we'll do another one because we have, what does a negative number look like when you do a negative, right? Well, the first thing you do when you do a negative polynomial, here we have negative 4a squared b minus 8ab squared plus 2ab. The first factor I see there is a negative 1. So the first thing, so let's factor negative 4ab first, right? I mean 4a squared b. That gives us negative 1 times 2 times 2 times A times B. Okay? And then we have negative 8AB, don't we? That gives us negative 1 times 2 times 2 times 2 times A times B. And our last term is 2AB. All right? So what do we have there? A 2 times an A times a B. What do we have? What's the greatest common factor in this polynomial? Well, the greatest common factor is going to be 2AB, right? Every term up here has 2AB in it. That's the greatest common factor that they have. All right? So we're going to pull 2AB out of all of them and see what we have left. All right? So 2AB times what makes negative 4A squared B squared? Well, negative 2A, right? And then 2AB times what makes negative 8 AB squared. Oops, I need another B up there, don't I? My bad. Excuse me. Yeah, guys, that would be 4B plus our last term, 2AB, is what we took out, right? So we'd multiply that by 1. So simplify. So if I pull out 2AB, I'm going to have what left? Negative 2A minus 4B plus 1. Now, if you're not sure if you're right, you can check your work by multiplying this times this times this, and this times this, and see if you get your original polynomial. All right. I bet there's a guided practice coming up for somebody. And here it is. Try those two problems, pause your video, and start it back up when you're finished. Okay. If you have 4 or more terms to factor, then you can, oh gosh, I can't talk right now. To factor polynomials that have 4 or more terms, you're going to do something called factoring by grouping. And that was another one of our vocabs if I'm not mistaken. So factoring by grouping is when you factor a polynomial that has 4 or more terms and you put them into groups, and okay, and then they're factored. Okay. Let's look and see what that means. First of all, to factor by grouping, there's certain things certain conditions must exist. Number 1, that you have to have 4 or more terms. Number 2, the terms have to have common factors that can be grouped together. And then the third thing, you have to have 2 common factors that are identical or the additive inverse of each other. So let's look at this example. We have ax plus bx plus ay plus by. Now we can group those ax plus bx and ay plus by because we have similar terms. We have common factors that can be grouped, okay? So first thing we did, we had 4 terms. There were 4 terms here. Then we could group them according to their common factors. And then something has to be identical or the additive inverse. And in this case, we have something that's identical. They both have an a plus b factor. If you pull out x, you get a plus b. If you factor just this term right here, you can pull out and get x times a plus b. And here you could pull out y and get y times the a plus b. Okay, now look what happens. Do you see that the a plus b, they have it in common? So that's going to be the second factor of your of your factoring of this polynomial. And the first term will be what you put on the outside, x plus y. All right? We'll try a few. I hear panic in your, or not panic, but stress. But we'll be okay, guys. Let's try this. Let's look at some numbers and see how it works when you have some numbers, okay? So we have 4qr plus 8r plus 3q plus 6. Okay, we have some like terms, don't we? And we have 4 terms, so we can factor by grouping. So the first thing I'm going to do is I'm going to look at these guys because I see they both have an r, and then I'm going to group these two together, okay? Now, what can I pull out of this? I can pull 4r out, and what do I have left? Q plus 2. Do you see why? If I pull the 4 out, that leaves nothing with this q. If I pull the 4 out of the 8, it gives me a 2 left here. And if I pull the r out, it's gone. Okay, and how about out of this one? How can we factor that? Well, we can take out a 3, can't we? That will leave us a q plus 2. And now do you notice that we have created we've broken this down so we have q plus 2 in both of the terms? Okay, so that means we can factor this by saying q plus 2 times, what do we have left? We have left a 4r plus 3r. So we'll write 4r plus 3, not 3r, but 3. And there we factored that one. All right, let's see how we're doing here. There you go. There's your guided practice. Here, there are 2 more to try to factor. Group them. We have rn plus 5n and negative r minus 5. So let's see if you can't group these and figure this out. That's the study tip we just talked about. If you want to check your answers, once you get an answer, use the distributive property and see if you come up with your original. It can be helpful to recognize when you have an additive inverse. It's helpful to recognize that 6a and negative 1 times the quantity a minus 6 are the same thing. Do you guys see that? 6 minus a is the same thing as negative 1 times a is going to be a negative a, right? And negative 1 times negative 6 is a positive 6. So that's the same as negative a, right, plus 6. Well, rewrite that, and that's the same as 6 minus a. So do you see how this and this are the same? Okay, I just want you to be able to recognize those patterns. That can be helpful when you're doing factoring. All right. Here we have a problem. I'm going to slide this up a little bit if I can. Oops. So we have more room to work. Okay, we're going to ooh, magic. Factor by grouping with additive inverses. Okay, so now we have 2mk minus 12m plus 42 minus 7k. Okay. Let's group them. I see some m's there. Okay, let's see what we can do here. If I take 2m out of my first phrase here, right? What does that leave me? In this first term, it leaves me a k. In the second term, it leaves me a negative 6m. Does everybody see that? Okay, let's see what happens when we take something out of the second term. Well, I see a 42 and a 7. I bet I can take the 7 out of there, right? And what does that leave me? 6 minus... Oh, I made a mistake over here, guys. Everybody probably caught that but me. Sorry, when I took that m out of the 12m, it just left me a 6 there. And now let's go over here. So we have take out a 7, the 42, that leaves us a 6 inside, and it leaves us just a k inside here. So now we have 2m times the quantity k minus 6 plus 7 times the quantity 6 minus k. Here we have an additive inverse. Do you guys see it? Right? Okay. So knowing that, we can regroup this and say that, how can we do this? So we can say k minus 6 for both of these guys, right? But what happens if we do that? What do we have to do with all of the terms? We have to multiply it by a negative. We're multiplying everything in that term by -1, okay? And that's how we get k minus 6, right? So then we have 2m k minus 6, plus, excuse me, minus 7 times k minus 6. All right, see how we got to do that? That way we have these two guys looking exactly the same. So then our second term is going to be k minus 6, and our first term is going to be 2m minus 7. All righty? Okay. Here are some guided practice problems for you. I think as you work through them, take your time, you'll start to understand how multiplying that additive inverse by -1 gives you the matching factors that you need to make this work. Good luck with this. And okay, guys, we are going to have one last thing we're going to talk about in this section, and that is solving equations by factoring. So some equations can be solved by factoring. Now, to do this, you have to keep in mind the idea that two factors multiplied together to equal 0. What do you notice? Here's another group that's multiplied together to equal 0. Here's another one. Here's another one. What do you notice about these? Yes, at least one of the factors is 0. We're going to use that thing that we know. If something equals 0 and it's a product is 0, we know one of the factors must be 0. So these are just examples of what we're known as the zero product property. So that's your third vocabulary word. Let's look at that property right now. Thank you. Okay. The zero product property states that if the product of two factors is 0, then at least one of the factors must be 0. If the product of two factors is 0, then at least one of the factors must be 0. All right? Okay. And the other thing I want you to keep in mind, and we're going to talk about this in a minute, a solution or root of an equation is any value that makes the equation true. And we're going to be looking for those roots. And we'll be talking a lot more about roots later on. So a root is another name for a solution to an equation. And probably more specific, a quadratic. But right now, let's just remember that a root is a solution to that equation. Okay. So here we have an equation. 2D, the quantity 2D plus 6 times the quantity 3D minus 15 equals 0. All right? Well, we know, because of the zero property, that either this or this must be 0. So there, could we find out what D might possibly be? Well, let's look at this. How we're going to do this is we're going to separate these out. We're going to look at this factor and say, okay, it's 0. And then we're going to look at this factor, 3D minus 15, and we're going to say it is 0. Okay? Let me see if I can move this guy down a little bit out of our way. Okay, thank you, buddy. All right, so how do I solve for D? Minus 6. I don't know how that did that. That's magic. 2d equals -6. Divide by 2, and we find out that d equals -3. The other possibility is over here, right? So we're going to do this twice. We're going to check on this one and on this one when it's equal to 0. Because we know, right, that if it equals 0, one of these two factors must be 0. So 3d minus 15 equals 0. Well, let's see. 3d, we're going to add 15 to both sides. We find out that 3d equals 15. Divide by 3 on both sides, and you see that d equals 5. So the roots of this problem are d equals -3 or d equals 3. Okay, that's not too bad. We've done something similar to that in other work, like with absolute value this year a little bit. But this is different, okay? All right. Let's see. Let's try one more thing here. Another example. C squared equals 3c. Okay, in this case, we have c squared equals 3c. Well, it's not equal to 0, but we could make it equal to 0, couldn't we? We could go 3 squared with minus 3c on both sides, right? I always tell you never do this. Well, guess what? We're actually going to do it now. Watch this. C squared equals 3c. I want 0 over here. So what I'm going to do, I'm going to subtract 3c from both sides. And I'll get 0 equals c squared minus 3c. Now I know that one of these guys, right? So now I'm going to factor out this phrase, right? And I'm going to factor out c, right? Both of these elements have a c in them. And I have a c left here and a minus 3 equals 0. Now I have two factors equal to 0. So I'm going to separate it out. And I'm going to put c equal to 0 and c minus 3 equal to 0. So in one case, if c equals 0, or if c, add 3 to this one, obviously c equals 0, we're done. Plus 3, c equals 3. So c is either equal to 0 or c is equal to 3. Those are the roots of this problem. All right? Just try a few of those. We're going to keep this pretty simple, so it's not going to get more complex than what we've looked at here. And here are a couple of practice problems for you. So good luck with those, guys.